Section 6.4 is called General Strategy for Factoring. Essentially what it is it combines all of our previous sections on factoring and mixes it together into one section. So we kind of need to know what to do because it's not going to give us much direction other than it's going to tell us to factor or to factor completely. And it's up to us to know what to do there. So rule number 1 is always factor out a GCF. So if it has a GCF, you need to factor that out first. It's possible it doesn't have a GCF, but always try to factor out a GCF if you can. If it has two terms, then it's going to be either a difference of two squares, sum or a difference of two cubes, or it might not be factorable. If it has three terms, you want to use the AC method. It could be a perfect square trinomial. If you watch my videos on that, I still use AC on the perfect square trinomials. Or it might not be factorable. And then if it has four terms, you want to do factor by grouping, or it could be prime. If it has more than four terms, then it would only be a GCF type of factoring. You couldn't do, if it had 5 terms, AC wouldn't work. It's not a difference of squares or cubes. Factoring by grouping wouldn't work. So if it's more than 4, which doesn't happen very often, then you would just try to take out a GCF. So this first question, I want to try to take out a GCF. And my GCF is 3x cubed y to the 4th, which will leave me with 6x to the 4th y squared minus y, and then plus 5x. Now this trinomial, this can actually not be factored further because of the variables here. So those are not in the correct form for you to do the AC method on. So this is actually our final answer. With number 2, I want to try to take out a GCF. That would be -6, and that would leave me with x minus 5. Now x minus 5 has two terms. Is it a difference in two squares? It is not, because x is not a perfect square and 5 is not a perfect square. So all I could do on this one is take out a GCF.